Perl Cabal, that's tilde util, my handle, and YAPC, that directory will have it. Okay. The Why of My, from Cargo Cult to Mastery via Perl's Fake History. The title in the schedule is Why My, but it's really the Why of My. And there's a bunch of questions that come up with Perlmongers, with my own programming, and I keep having to go back and reread the documentation. There are things that aren't quite clear. It's not the documentation's fault. I don't have the mental hooks to remember them. So I keep having to relearn them, especially namespaces. I think I relearned namespaces 10 times over the course of my career because it's all presented OO style, the old family names example. Doesn't work for me. So the Why of My, that's me, with the thoughts not quite sticking. My little Scooty Puff Jr. And this is what we want. Everything very well filed. When I learned some of this from the context of what was the reason, what was the need for the different elements like local and hour, it all made sense, and I don't have to look at the documentation anymore. The documentation, by the way, is wonderful if you already understand it. I let a dozen very smart people of Atlanta PM struggle with this just to see what they would make of it when a question came up about hour, and I just look at that and tell me what you think. And wow, it's if you don't already know namespaces, if you don't already know lexicals versus packages, you're not going to get a very good answer as when you should use my versus when you should use our by looking at our docs. Packages, not much better. The concept for this talk was inspired by and influenced by the book Design Notes Log by God. It's a physics book. I have it here if anybody wants to see it later. It's kind of thick. Universe is complicated. And it starts out, that's not the God, it's just the general operations director of the universe. Starts out, there's nothing. He invents mass. We have two pieces of mass, that creates length. When you start moving mass, that creates time. It's really interesting, but it's a notional history. God didn't really write it. And this is also a notional history. There are several things that I will say in historical context that are not accurate history, because I am not a historian, I am a storyteller. And where it makes a better story, I will lie to you. As our dramaturg says whenever we do Shakespearean history plays, she makes us take the pledge, I promise that I will not learn history from Shakespeare. Don't learn Perl's history from this talk. So let's go back in the distant past. Like just before Perl 1 came out. Perl almost 1. So lots and lots of stuff that you would not expect to have been in Perl 1 was actually there, like regular expressions. The scaffolding for the variables that you use, scalars, arrays, hashes, is there. But the variables aren't there yet. That part hasn't been implemented. So how do we create variables? How do we make that exposed to the programmer? You could do it like this. First let me say, the scaffolding for hashes are already there, and since a variable is just a name connected to a container, and hashes are about name lookup to a pointer, it makes sense to use the scaffolding that's going to support hash variables to implement variables themselves, which is what Perl does. Very clever. You could say, since Larry's wisely declared we are going to have overlapping, you can have $foo and @foo and %foo. How do you implement that? I could have a hash for all the scalars, and a separate hash for all the arrays, and a separate hash for all the hashes, for each of the types of things, the sigils that we're going to support. That's the way I would have done it. Larry, for clever reasons that'll become apparent later, said, no. What we'll do is we'll have one hash instead of a bunch, one ring to rule them all. And if you have $foo and @foo, that foo will be looked up in that one hash, and then there will be a pointer to whether you're talking about the scalar part or the scalar version of it or the array version of it. Great book on the internals of Perl. It's out of date and still wonderful. This is the actual structure of what I was just diagramming. Yes, the old one. Yeah, the talk's inaccurate both historically and future dated. So the structure for these hash like foo, when you gets looked up in the hash, the thing that holds all the pointers to scalar array and hash and all that is called a glob. So there's the G, and that is for glob. And here's the structure. So this is going to be the pointer to the scalar. That's going to be the pointer to the array, to the hash, the code, because you can have a subroutine named foo too. The IO and form. Nobody uses that anymore, right? And you can look at this yourself with develpeek. I've got a little program here that I've written, and I'm defining a scalar Z and a array Z and a subroutine Z and a hash Z, and I dump it, and that's just copied from the previous slide right there. There's an address for scalar. If I took this part out, that would become 0, SV equals 0. So now we have the structure to implement variables that Perl itself gives you, like what operating system, or user exposed variables. So this is everything we need, right? We're good to go for all of eternity. This is a fine implementation of variables. No, there are problems. One is recursion. If you are calling a subroutine from within a subroutine, then you're fine as long as you don't want to save state. Because if there's a variable in there, it gets clobbered every time it loops through. When it comes back, it doesn't have the variable it left with. Also, if you're working on a program that's bigger than your head, so you can't remember every piece of it at every moment, or if more than one person than you is working on your program, you could collide. You could use a variable name that somebody else used somewhere else. And if one subroutine calls another, then you get a very bad action at a distance bug because their subroutine overwrote the value that you did not expect to change. So you can't make a very big program unless you take care of that problem. Well, local was added to take care of both of those. Local does a very specific thing. Oops. It takes the old value of the variable and saves it. And then when you leave scope, when you exit the subroutine, where you did the local, it pops that old value off the stack and replaces it. That's all it does. Remember I said earlier, you could have implemented recursion if you were managing your own stack for every single variable, which is how they did it in Perl 1. Now in Perl 2, with local, it automatically handles that for you. It essentially is implementing one of those stacks for every single variable that you localize. So now we have recursion and some protection. There's still ways that you can call subroutines that is not insulated by local. But here, this is what I was talking about. If you don't have local and A calls B and B calls C, then when you return from the call to B, zip code got clobbered. And if 3 people are working on this, these two people, A and C, don't know to talk about what variables they're using and protecting from each other. It quickly turns into a problem. Localizing, now you've got safety. But remember how I just described how local works? It saves it on a stack, and then at the end it pops it back. That's slow. So people only use local when they need the safety, which means they have to spot that they needed the safety, which means that they don't use it enough. If you have to choose when you're going to be safe, it's like putting on your seatbelt. Until there was a law, many of us didn't. So we had a mechanism for safety that was very, very underused. But in the actual Perl 2 release, recursive subroutine calls are now supported. So this problem of collisions, we don't want to use local all the time because it slows us down. So let's just come up with a convention for making sure that we don't have collisions. Let's say, my name is Robert Bruce Gray, and so my initials are RBG. I'll just put RBG underscore in front of every single variable that I use. I'll prefix it. And that's guaranteed to work because no other programmer that could ever work on my code, or that if I'm writing a library that their code will use, no other programmer has my initials. See, here we're at the point where we want to start sharing code, and this problem of collisions becomes a real problem. A real problem. It's going to affect how big the CPAN that doesn't exist yet can ever be. If there's this collision problem, it limits, because the bigger it gets, the worse the problem is. But it's a great idea. So RBG, and I'm dealing with colors. So my first color variable is called 1, but instead of calling it color 1, I'm going to call it RBG underscore color 1. Yep. Oh, there is another guy with my name. There's Robert Bruce Gray, and he's the actor that played Surak, the father of Vulcan Logic, on Star Trek. So Logic, we know he's a programmer, so there goes my my insulation against collision. Also, there's another problem, because that underscore there, that's a regular part of a variable name. So if somebody's using colors, not everybody says red, green, blue. Some people say red, blue, green. And so this is it in one color space, and this is it in another color space, and that's completely legitimate code to write. And if they're using my library, then I'm going to overwrite something of theirs. Bad. So what problems do we need to solve now? We need safety, get rid of the collisions. We need clarity by changing that separator from underscore to something that you can't use in a variable name. And we need to stop the carpal tunnel that we all are going to get from typing our initials in front of every single variable that we have. So computer science has a solution for this. It's a great advance in language technology. It's called namespaces. And some people got a little irate about the whole issue of languages that don't have namespaces. This is back in 2005, and I had a discussion yesterday. In 2012, JavaScript still has a terrible problem because there are no namespaces in it. So that was quickly added. The way we access namespaces in Perl is the package statement. So just to give you this namespace concept, this gentleman here, this nice volunteer, is Krishna. And if I am to speak of Krishna, and my body language indicates that I'm talking about this front row here, this front table, then everybody who's paying attention knows I'm talking about this Krishna and not another Krishna. If there was a second Krishna at that table, then we'd have to have some way to distinguish it. If I was not signaling with my body language that I was talking about the front table, then I would need to refer to his full name, fully qualified, in order to not collide with another person that I might be talking about. Similarly, if, even though he's not at this front table here, that my body language is oriented towards, if I refer to Larry, you all know that I'm talking about Larry Wall because we are at a YAPC conference. If we were at Oracle conference, then if you said Larry, you would be talking about a different Larry. So we have to have this mechanism for saying which person or which variable we're talking about. Package says from now on, it's the body language, from now on, everything that I say, if I don't specify a full name, it has this name. It's an automatic way to prefix. It's the fix for carpal tunnel. I said the underscore was a problem, so we have the double colon separator. That was actually added in Perl 5. We had namespaces in Perl 4, but we used a different separator, the single quote, which is still around. It's how the Do module works. But the double colons are much better. So we still have the problem of I can't use my initials. It's not distinct. It's not unique. If we've got package to automatically set our prefix, we still have to have a mechanism to come up with a prefix that nobody else is going to use. And we don't have that. But we are starting a mechanism for module names, not namespaces, but module names. If I create Acme Coolness and upload it to CPAN, which is our mechanism for sharing code, then nobody else without my permission can upload a module called Acme Coolness. I own the namespace. So if we just adopt the convention that we will always use a module name as the package name, now we have achieved that insulation that we need. Now we have unique prefix that will never get clobbered. Now we can grow CPAN as large as it can otherwise grow without ever having the limit of whenever you use somebody else's code, you have to read every single line because you don't know that it might collide with something you're doing, which is where JavaScript kind of is right now. Okay, first, I don't completely understand the question, although I get basically what you're talking about. But even if I got it completely, I don't think I could answer it very well, especially in this time. Would you talk to me later about it? And I'll be glad to talk your ear off about and get a better understanding. Okay, other questions? This working for everybody so far? This is sort of an experimental way of presenting the information. I want emails from all of you in 6 months as to whether this all stuck in your head or not, so I know the experiment's a success or a failure. Or you could just fill out the YAPC speakers talk survey. It's very appreciated. So now we're safe. We are safe, but we are still slow, even if we don't use local. Because remember how I described it? When you use $foo, it's got to look it up in a hash and find the glob for all the foos, and then it's got to go over and find the scalar slot for the scalar of foo. That's a double dereference for every single time you read or write to a variable. That's slow. So, great concept. Lexicals. We talked about lexical scope a little bit before. It was implied. I said when you come out of the subroutine that you did local in, it pops it off. Well, that subroutine is just one kind of lexical scope. Basically, everywhere that you put curly brackets, that is not a hash dereference or maybe a map. You're creating a lexical scope. An if statement, you got curly braces. A while, a subroutine. These are all, if you just put bare curly braces, you've created a lexical scope. And you could use local to localize something in there. Let's make lexical variables. If we make a place inside, just imagine that it lives inside the left curly brace. Imagine that all lexical variables in these scratch pads I'm going to talk about, that they live in microscopically inside the left curly brace. If we do that, and we say we're going to have variables that live there, well, those can be spotted during compile time, and we can create a little array inside there. The scratch pad is essentially a microarray, and replace the name with a pointer to the right slot in that array. So now we've got speed of reference because we're not doing that double dereference. We can go straight to the scratch pad. And we don't have to do the second part of the dereference because it will consider @x and $x to be separate things instead of fusing them with the glob concept. So that's great. That'll speed us up. And this is the structure to do that. This is the structure of a CV, a code value. So any of those lexical code blocks. And there's CV, and there's the pointer to the glob that owns it, and there's the pointer to the pad list, that scratch pad. So if you were to look in memory there, you would find your variables, all the variables that are lexically defined within that scope. And that's one of the worst lies I'm going to tell. It's actually, the scratch pad is actually much more complicated than that and tracks more than that. But this is the cartoon version. And this is a diagram from that book earlier of the scratch pad. It also keeps track so that if you have a problem with this slot right here, it can tell you what that slot was. So if it's optimized away the name and it's just considering it a pointer to right there, it can look back if it's going to give you an error message and tell you what variable was associated with it. So that's great. We have lexical variables. How do you tell it that it's lexical instead of the old style, which we haven't given a name to yet? My. My says this variable is a lexical variable. Makes an entry in the lex pad. That lex pad lives inside the curly brace, therefore if you're outside the curly brace, the variable does not exist. You cannot refer to it. There are fancy ways with closures that you can save it and it will handle recursion, but you can't refer to it. So many of the problems of isolating code go away because you can't have a collision to a name that you can't access at all. So if you have a lexical variable inside this scope, nobody can muck with it, not even you outside that scope, unless you do something like take a reference to it. So the point here is that that's like the lex pad, and address is defined second, so it's in slot 1 there. And instead of address equals 15, the compiler can internally replace it with lexpad element right there equals 15. So it doesn't even have to pay attention to the names anymore if it can optimize them away during compilation. So we've solved all our problems so far, but we're making big programs now, and we're using this a lot because this is a great language. But we're human, and we have typos. We would like to be able to catch the typos. So, great notion, strict vars. When you say use strict, it actually does 3 distinct things, and one of them is use vars. The other 2 I'm not going to talk about. Strict vars. Strict vars says declare all variables or fail. Declare if the compiler is compiling your program and you refer to something that you haven't declared yet, then it stops compiling your program. It won't ever try and run it. It just stops. So, great. All our typos are now caught. This is a big improvement. This is why we pound on you on Perl monks, use strict. Important distinction. Because we're using my to also declare the variable for strict purposes, and because the first and main way that most people interact with my is, oh crap, I'm using strict and I got an error because I left out my there, I'm going to add my. Everybody starts thinking my is all about strict. It's not. My is all about lexicals. Lexicals are a completely different storage class than the old style variables. They're used for different things. They're optimized in different ways. They are different universes. My is to put your variable in the lexical universe. Strict is just a bonus effect. So, great progress, but now our old style variables, which I'm going to call package variables, because everybody else does, we have to have a way to declare those as well. So they came up with use vars and just put all the package variables that you're going to use in that statement, which worked fine for a long time. But weren't really happy with it because it means that you had two substantially different ways of declaring variables, which should be okay because they're two completely different kinds of variables. But people said, I want to be able to declare the package variables in the same way that I declare lexical variables. In fact, I want to be able to limit it by lexical scope. So if you use this, it declares it for the entire file. And what if you only use that package variable in one very narrow scope? You'd like to be able to not open up typo collision past that scope. So we introduced our. Our works like my, but it declares a package variable instead of a lexical variable. And that created a problem. That created the confusion because they look very identical. They look very similar, nearly identical. In fact, you could be declaring a program, declaring a variable, and interchange them often, and they just work. They're doing completely different things, but it's invisible to most people, and a lot of modern programmers don't even know about package variables in the first place because they're used less and less now. So we see this all the time. Should I use my or should I use our? Use my, it's faster, and a lot of other reasons it's safer. But they're completely different things. It was surprising to me that this occurred. But we see it all the time, this confusion. They're not interchangeable. They look interchangeable. Often, if you say our instead of my, you are opening yourself up to deeper bugs later on. But our was added for strict. My wasn't, but our was. It's just a better use vars. Yes?
Are you saying it's equivalent to use vars?
It's equivalent, except it's tighter in scope. If you do it inside of curly braces, then it only has an effect within the curly braces. Once you get outside that curly brace, it's like you didn't do it.
So it makes a package variable limited to the scope of those curly braces?
Yes. And the package variable actually exists everywhere. And if you fully qualify it, like if I use Christian's last name, if you put the package in front of it with like Acme : coolness : variable name, then you can still get to it from anywhere in your program or anywhere in the code that's calling your code, somebody else's program, which is how Data Dumper lets you set a lot of its stuff, a lot of its internals. Did that answer your question? You haven't heard of a lot of this because we have better ways to do it. File find and Data Dumper use this mechanism to either export or import information on how they should work. And our OO interfaces are better than that. So the reason you haven't heard about it is there's better ways to do this. There are a few little tricks that package variables are occasionally useful for. One of them, the coolest one, didn't make it to the slide, but at the same place that I pointed out you could get this slide, there's an old command line talk. And if you look at the y.pm module from that command line talk, it's a very cool, sneaky way to use some of this. But if you had shared variables and you wanted to isolate them from the rest of your program, but you wanted these subroutines to use them, then you could create an artificial lexical scope to do that. And that makes sense, and I do that, as long as these subroutines should be grouped together. But sometimes they have to be grouped otherwise for other variables that are shared. So how do you do that? Well, a sneaky way is to say, instead of doing it lexically, we'll do it with package variables. I can say, without an extra scope, so I can put these in any order, shared var1 is in A, and it's shared with B, and 2 is shared between B and C, but if C tries to use this one accidentally, it can't because it's not declared inside of its scope. That clear? That invoke any other questions? Or inspire? Yes, sir.
Yeah, well, weren't you just saying if you want to use this package variable outside of the scope of those braces, you have to prefix it with something identifying where it came from.
Yes.
But you're saying our in sub A and our in sub B for var1, it seems like they both want their own version so that you have B shared var1 and A shared var1.
Well, they don't want their own version. They're using this for surreptitious communication between them. They're sharing the variable.
But then I'm just saying, but they each kind of act like I'm independently declaring this variable. And I'm just uncomfortable with them both asserting, I have this variable, I made it.
And I think it should make you uncomfortable. It comes from the my instinct, because you read my just like our. It looks like I am declaring this for myself, but that's my in myself. Our says I am declaring that I am using our variable, our shared variable. Okay? That work? I just came up with that. Yes, sir.
Do you still have to instantiate the variable our, or does it automatically whichever one?
Our does not, well, our is not the normal mechanism for instantiation. Instantiation occurs just by any kind of use. But because if you are using use strict, you can't use the variable before, well, I guess you could by giving it fully qualified. Yeah. I'll say it does have the effect of instantiation, but that's not the intent of it. It's just a side effect of, like my, it will let you can have an inline assignment of it. In fact, that's a good question. I'm not sure.
I don't think it's instantiated. Our just prefixes the variable name with the package. It's fully qualified in.
Yeah, if
shared var1, I really need
uh,
acne, colon, coolness, shared variable.
and
It's
actually,
really just an alias.
yeah,
Just creating an alias.
I wouldn't be.
It looks like a lexical variable name, but it installs a lexical variable name, but instead of actually having a slot there, it just points off to the package.
Yeah. Okay. Great. But still, if you had not said that, I would say I would not be surprised if it worked one way in one version of Perl and another way in another, just because it's a very subtle point.
But in terms of instantiation, it doesn't actually do anything at runtime unless you actually assign to it. It's just an assignment.
So then if you had a my shared var1 in the same lexical scope, you couldn't let it as a different variable.
No, it collides.
it collides in namespace. I mean, namespace reuse there. It collides because it's just like if you said my shared one and my shared one. Those two, you'll get a problem because you've redeclared. Well,
But if our is an alias to package,
because that's usually what you want to happen. That's usually what if you are trickily using the same name of a package variable as a lexical variable, that's probably not what you intended to do in the same scope. Usually, if you need to mask the package variable, you just use the lexical variable, and it works fine. You don't have to care that there was a package variable. But if you want to use them both at the same time, you should use a different name for your lexical variable. I don't know how to answer that better than, because it's usually the way it ought to work. Yes, sir.
I've been thinking before coming to that, I guess I still think of it correctly, that an R variable is equivalent to declaring a package, or I think it was sort of equivalent to the package variable at the top of the file and just using it.
Well, let me say it this way, if you finished your question.
Yeah, that's
Here's a question to y'all that'll shape that. If you don't use strict, if use strict is not in effect, then what does our do? Technically, it does a little something, but effectively, it's a null op. Okay? My shoves it into the lexical world, makes your variable lexical. Our is just to carve out for strict to say not to yell at you about it. And our does that in a lexical scope. So it only gives you the carve out in that scope. Whereas if you use use vars, it's for file scope, and if you use the full package name, then all bets are off, because strict will not ever bug you about using a fully qualified package name. Warnings will, if I try and set something, that's a 40-minute mark, in data dumper use QQQ, when it's really use QQ, then I will not get a problem from strict. I will get a warning that that variable is only used once, but that's the best it can do. And if I mistype it twice, then I'm just boned. Did that answer your question? Okay. Questions? Yes, sir.
Yeah, something that's always puzzled me about is certain variables cannot be declared mine, like record separator. I assume that's because they're essentially always package variables, so therefore declare something by that
Well, yeah, they.
$/.
Yeah,
Yeah, I mean, what's going on there is that the actual storage location, that the kernel is going to use for the effective $/ is global. It's a global storage location, so if you could declare a local one, you could change the local one, but it still would not have effect on the global behavior kernel.
yeah.
Now, it's arguable whether that should be a global behavior kernel. We thought some of those things, but there are things which actually are outside of any package, or you can think of it the other way. They're in every package. It's sort of magical list of things, and things like standard out and standard in. They're magically in every package. Some of those. There's some others that are like that. One of those messy areas and sort of. Yeah, well, that's one of those things that we were only able to fix in Perl 6 because we decided to break that.
Yeah. And I think it really works better to say there are some variables that the system has that you can't name things like that, because that way there can never be serious confusion between them. You can't be making variables that look like system variables, and we did that more in Perl 6. That's even better. Yes.
That's because all it does is swap out the global value. It doesn't change the location to a different location. Yeah, it's just juggling the value of the global area.
Something I skipped over that I'll continue to skip over is aliasing, which is a cool thing that you can do with package variables, but you can't do with lexical variables. You can't localize a my variable. You can't my package variable. They are completely different worlds. They're used for completely different things.
Yeah, well, that's another thing that's only true because the language designers.
Yeah, some of this why don't we have lexical subroutines yet? Well, we could. I think it's just nobody got around to implementing it in Perl 5 yet. Based on all the structure.
You actually notice that we had the syntax for declaring a my subroutine for years and years. Nobody ever implemented it.
Yeah. All right. What else? Yes, sir.
So back to that previous slide. We declare our shared var 1 up top. Down in B, I think you're saying I wouldn't necessarily have to say our if I give it the full package name, which I'm rusty. I'll say name : shared var 1.
Yeah, you could say $main : shared var 1, and you could use that instead of our. Yes, because there's no package statement there. They're all in the same package. Pardon?
But strict doesn't check.
Right. If you fully qualify, put the package name in front of the variable, then strict will not touch it. It just carves out for it automatically. Hands off of those. What else? Yes?
If you declared our shared var outside, above all those scopes, then it would basically obviate the use of our shared var 1 in any of those individual scopes, right?
Right. If you try that trick with my, when he's saying if up here you said our shared var 1, wouldn't it just make it where you don't need to put it there and you don't need to put it there? And that's correct. But it would take away your insulation there. That we want to be an error. That's why we didn't put our there. And if you had it up here, then this would magically start working, which is what we don't want. But yeah, you're right about the effect that it would have. If you did the same kind of thing with my, you had my here and my here, then this my variable is different than that my variable. But I'm pretty sure that you don't get an argument from or warning of anything of multiple declarations, because these are in different scope, even though you're talking about the same variable. This is why when people say, I'm trying to make something use strict clean, I'm going to go in and put my everywhere that I think I need to. Okay, it didn't work there. I'm going to try our instead. Fail. But everybody does it. I mean, everybody that I've had to deal with. And that may magically make it work. You put our there, and now it starts working. But, anytime you just like, oh, that didn't work, let me try this, but you don't understand what you're doing, you're cargo culting. Or at least just experimenting with things that you don't understand. And that's not the way we want to create software to be proud of. It's reliable. So now hopefully you understand this well enough to know why not to. Yes, sir.
So I think I understand
Okay.
but I didn't get it. And I'm not confident enough to change that. Submit a patch to change that.
Okay.
But there are people here who
That's a very good point. There's been an initiative in Perl documentation to basically say, like in Perl Func, I think they were talking about last year, have examples for every single thing, even if something above it you could refer to and imply how it works. I think that a micro tutorial in this would be a good thing to put at the tail end of the rest of our documentation. Same thing for or at least a pointer to some conceptual piece of documentation to explain the concepts I've been going over here. Maybe it shouldn't take 50 minutes to read, but that's a great point. Thank you.
And let me say, I now have a commit bit to Bill 5, and I was skeptical about patches being developed. And so I started out with just little things, and lo and behold, some of them were accepted. And so it is true that patches developed.
And congratulations on your commit bit. Yes.
One last question. So, our is in declares shared var, shared var 2, for example, but only from that point forward in the scope.
Right. It does. When I say lexical scope, that's a good point. It's actually from that point forward in the lexical scope. It doesn't magically declare it back, even though this is technically in the same scope. It's forward in the scope.
Okay.
Good point. What else? Yes, sir.
The main place I feel like I see power and while is declaring your export, using
Mhm.
exporter package. Is that because the exporter is actually going in and using your fully qualified export okay, and it's doing whatever package it's doing?
Basically, yes. And by the way exporter works is essentially aliasing. I mean, there was a whole section of this talk that didn't fit on how the magic of exporter is really just a couple of linking of those glob structures behind the scenes, and it's very simple and cool, but you don't want to type that much code every time, so you just use exporter. But yes, what else? Got to wrap it up. Yes, sir.
What to add the
It does. Oh, that's great. I got to check it out. Okay, I'm very interruptible the rest of the conference. If you have other questions, special thanks to Atlanta Perlmongers who endured a 2-hour, 1-slide version of this talk. I hope you go forth and enjoy the rest of your conference. Thank you for coming.